Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 8, Section 5. This begins our study of logarithms. Now, logarithms have many useful applications in math and science. They're used to measure a wide range of very small numbers in the pH scale, in the Richter scale, measuring the brightness of stars. Logarithms give us a new way to solve problems with finances. When the x is up in the exponent, we've never been able to get it out of there before except like bases, and this gives us a method to use with any base. So they are extremely useful. So let's begin with just an introduction to logarithms, what they are, and how to convert back and forth between exponential and logarithm forms. So by definition, logarithms are the inverses of exponential functions. So that's the reason that we studied inverse earlier in this chapter. So I drew an xy grid over here, and this is the line x equals y. And you'll remember that inverses are mirror images of each other over that line. So to define a logarithm, let's first look at the graph of the exponential function y equals 2 to the x. All right, so I attempted to graph this the best I could in the red graph here. This picture is also in your book at the bottom of page 354 if you want a more precise graph. So we graph this function y equals 2 to the x, and now to find its inverse, you know that we have to switch around the x and y and then solve for y. So let's do that. Except in this case, we can't solve for y. All we can do is switch them around because we don't have a method to get this y out of the exponent. So let's graph this over here on our xy axis and take a look at what we have. All right, so I attempted to graph in blue here the best I could, x equals 2 to the y. And the t-charts for both of these graphs are on page 354 if you want to take a look at them. And you can see they clearly are mirror images of one another over the line y equals x. And then the question I have for you is, can we get this y out of the exponent? And right now we can't, and soon you will have a strategy to do so, and that will expand your algebra skills to be able to solve for those variables that are tucked up in the exponent. So to get the definition of the word logarithm here, this y up in the exponent, this y is, it's called the logarithm of x. I always have trouble spelling that word, so I'm going to just make sure you guys can't laugh at me. Logarithm, oh man, logarithm of x. And so what you'll hear me say many times in this chapter is that the exponent is the logarithm. The logarithm is the exponent. They are one and the same. So when you use the word logarithm, you're really saying the word exponent. And that is why we had to learn the rules of exponents so thoroughly, because now all of those properties apply to logarithms. So now we need to learn how to convert the exponential form into the log form, just how to write it. So this is a writing lesson. So when we have x equals 2 to the y, remember the exponent is the log, so you take this exponent and you remove it and you pull it and pull it out of there and just write the y. Now in this, clearly the 2 is the base that has the exponent of y. And in logs, the base is this little subscript here. So we read this as log base 2 of x. Remember, again, I can't repeat this enough, the log of a number is the exponent when it is written in the power of b, meaning base b. So just look at this is huge right here to understand how to convert between log and exponent and log. We need to be able to go both ways very fluently. It could be very helpful to put this into words for those of you who prefer that. So another way to state this is the base to the exponent equals the answer. And then when you convert that, the exponent equals, we got to put the word log in here, log base whatever it is of the answer. Okay, so write that in if that helps you to see this in word format. So now let's look at some examples of converting back and forth. Here in exponential form, we have 2 to the 4th equals 16, and to write that in logarithmic form, we add, of course, the word log, and the base is the subscript, so the base is 2. So we say log base 2 of 16 is 4. And now to convert log to exponent, again, the base is 10. The answer is the exponent, so 10 to the 3rd equals 1,000. And then to go backwards with this one, and there's the bell. Again, 10 is the base. The exponent is the answer, so we have a 10 to the negative 2 equals 0.01. And then converting this one to logarithm form, again, the base is 2, so we have log base 2 of the answer, 1/8, equals the exponent of negative 3. So you'll be asked to do some convert like this in your assignment to practice this. In this example, we're asked to evaluate log base 2 of 64. So let's do this without our calculators. If this equals, whatever variable you want equals y, then we can convert this into exponential form. So we're saying that this is the base, 2 to whatever exponent, 2 to the y equals 64. And this one we can kind of do by like bases, because 64 can be written as 2 to the 6th power, and therefore we know that y is 6. And like I said, we will be learning this on our calculators too, but your brain has to be ahead of the calc and know what it's doing. So I'm thinking this next one could look familiar from what we did in the last chapter with like bases. So this is base 3 to some power, say x, is equal to 1 over 81. And we know that that would be a negative exponent, that 3 to the x would equal, and it's 3 to the 4th, I think, so it's negative 4. So in this case, x equals negative 4. Here, 5, the base 5 to what power gives you 25? And you can just do that one mentally. Here, log base 2, so we have 2 to what power is equal to 1/2, and that is a negative 1 power, so x is negative 1. So now that you've seen this, knowing what you know, can you go ahead and try these on your calculator using the log and then the different base menu, and see if you get these same answers. So the next question you should ask me is, where is this log base math on my calculator? And there's the other bell. So like I said, you need to go to the math menu and then scroll down, and the option would look like this. It would have log, and then it would have a capital in all caps base. Now, there's a difference on your calc. You can't just hit the key that looks like this and has the word log on it, because this key is always, always in base 10. And when we have different bases, we need to use this from the math menu. So go to the math menu, scroll down to log base, and then enter, well, whichever one of these you want, log base 3 of 1 over 81, and make sure your calc is telling you negative 4, so you know how to use that function on your calc. Okay, it looks like on your notes now I've given you some space to graph these two, to graph the exponential function and its inverse, but I kind of already did that in the introduction. And if you want to look at that graph, again, just to remind you, it is on page 354, and I think that's extremely helpful for you to understand that graph so that it makes sense to you where logarithms come from and how they're defined. All right, now let's talk more about coming back to that key on your calculator that just has the word log on it. This is called a common log, and like I said, it is base 10, but we don't write that. When you see the written just log of x, we understand that that plain log is a base 10, which our number system is base 10, so I hope that makes sense to you. So just remember, when you see a log written without a base, we all understand, we know that the base is 10. And those are very easily done on your calculator, or you can use tables, logarithm tables, to look them up. All right, so try just a couple so you're familiar with this. When you hit log and then you enter 100, what you're asking the calc is base 10 to what exponent gives me 100, and of course your calc would tell you 2. When you enter log of 1 over 1,000, you're asking your calc 10 to what power gives me 1 over 1,000, and I hope your calc tells you that that's a -3. So now let's get to a more interesting log. Here we're asking the calculator 10 to what power is going to give me an answer of 30. And of course, here's where the decimals come in. Now, when you do this, you punch it on your calc, you get a very long decimal. And in logarithms, we don't want to throw away too much accuracy. So it has become a common accepted practice to round a logarithm to 4 decimal places. So I'd like you to follow that. All the log tables are given with 4 decimal places. So please don't round off too much, or like I said, you're just losing all your accuracy. So when you do this, round it to 1.4771. And if you want to go ahead and check that, you can enter 10 to that power and see if it does give you 30. All right, I think that's all you need for your introduction to logarithm functions. So have fun with logs.